Okay, so it says determining one-to-one functions. For each set of ordered pairs, determine if it represents a function. So you got to first see if it's a function. And if it is, then is it a one-to-one function? Okay, so the first one I'll just do with these ordered pairs. I check to see if it's a function. So I'm looking at the inputs, the x values. Are they all different? Yep, -3, -2, -1, 0, 1, 2, 3. So yes, this is a function. Now, is it one-to-one? Now I have to look at the outputs. So I got a -6, a -4, a -2, a 0, a 2, a 4, and a 6. I don't see anything repeating, so I say it's a one-to-one function. So it's a function, and yes, it's a one-to-one function. Okay. The second one I'm going to do with a mapping. Just, you might find this easier to look at. So what are all my inputs? Well, I've got a -4, a -2, a -1, a 0. I need a bigger circle, don't I? Okay, let me redo that. This is why it's a little trickier. But visually, it's kind of nice. Okay. So I've got a -4, a -2, a -1, a 0, a 1, a 2, and a 4. Those are all the inputs, right? All the x values, all the domain elements. Okay. Then what are the outputs? Well, I've got an 8, a 4, a 2, a 0, a 2. Uh-oh. Well, I don't do that, do I? I don't write it twice. That would really mess you up if you did that. The 2's already there, so right there, and right there. So I got a bad feeling about this. And then I've got the 4 and the 8 again. So if I draw the mapping, each point is an arrow. So -4 is mapping to 8, -2 is mapping to 4, -1 is mapping to 2, 0 is mapping to 0. So far so good. But then 1 maps to 2, 2 maps to 4, and 4 maps to 8. So is it a function? Yes, it is a function. You only have each domain element going to one range element. But is it a one-to-one function? Not one-to-one. Because, you got 2 things going to 8 and 2 things going to 4. All right, so you don't have to draw the mapping, but sometimes it helps visually to see that. These are both finite sets, so we'll show you some other stuff we can do with one-to-one functions. Okay.